Before watching the video, do subscribe my channel and hit the bell notification icon to get the instant update. After the category of reduction, we have the category of oxidation. And even oxidation part we have already studied for aldehydes and ketones. If I talk with respect to alcohol's oxidation, I have discussed three cases. A primary alcohol on oxidation gives aldehyde, and aldehyde further oxidizes to acid with same number of carbon atoms. Secondary alcohol, ketone, and ketone ka vigorous oxidation gives you acid with less number of carbon atoms. Tertiary, very difficult to oxidize, so even if it is forced to undergo oxidation, it will undergo dehydration to form an alkene. Then alkene ka vigorous oxidation to ketone, and ketone ka vigorous to give you acid with again lesser number of carbon atoms. Okay? So we have already observed that out of aldehydes and ketones, the oxidation is easy for aldehydes, because aldehyde have this H which can be converted into OH and thereby it can be converted into acid. But ketones mein there is carbon bonded with R dash, so I have the CC bond. So if I want to oxidize this, I have to break the CC bond, and CC bond being very strong and stable, ketones would be very difficult to be oxidized. Clear? So if I have the oxidation done with the help of mild or a weak oxidizing agent, अगर weak oxidizing agent है तो it will affect only aldehydes and not the ketones. So this concept of oxidation is now used to distinguish between the aldehydes and ketone. Hence the oxidation is used as a distinguishing test between aldehydes and ketones. Clear with that? Now since aldehyde undergo easy oxidation, that is why they could be termed as strong reducing agents. They are difficult to oxidize, so they will be weak reducing agents. So now if I have weak oxidizing agent, it can affect the strong but not the weak, and that's the concept. Okay? Now three of the weak oxidizing agents which are used for differentiation are Tollens, Fellings and Schiff's. Tollens reagent, Fellings reagent and Schiff's reagent. उसी के बारे में डिस्कस करेंगे. The first one is Tollens reagent, or the test is referred as Tollens test. Now first of all, Tollens reagent is ammoniacal silver nitrate. Chemically, the reagent is named as ammoniacal silver nitrate. Perfect. This is the same silver mirror test. Now the ammoniacal silver nitrate is a complex of silver which is having the formula AgNH3 twice cation and OH minus anion. And the ratio in which this is used in the reaction with the aldehyde is 2:3. Meaning 2 moles of the cation and 3 moles of the OH minus. Directly remember for balancing, otherwise complicated ho jayega. So we have the aldehyde and the Tollens reagent, which I am writing as Tr. Okay? And the cation anion used in the ratio 2:3. Now if I warm this a bit, what will happen? The aldehydes, being strong oxidizing agents, undergo oxidation, and aldehyde oxidizes to give acid, so it will be RCOOH. But there is a presence of this base, so the acid would get converted into the salt. So I am just writing the anion of the salt as RCOO minus as the carboxylate ion. Plus, since this is a weak oxidizing agent, it will itself undergo reduction, and this silver plus would reduce to silver 0 and form a precipitate. Silver precipitate. So when you perform this reaction in the laboratory, in the test tube you have a solution of aldehyde, and drop by drop you add Tollens reagent on the sides of the test tube. जैसे ही रिएक्शन होगा, the silver will get precipitated and it will actually get deposited on the sides of the test tube. And if the silver is pure, you will get the appearance of a silver mirror. That is why famously this particular test is called or referred as silver mirror test. Silver mirror test. Okay, and for that obviously the silver needs to be highly pure. And if I balance of the reaction, Ag would be twice plus ammonia. If you see, it is NH3 twice, and this too will eliminate 4 moles of ammonia plus 1 of the H from the aldehyde and 3 of the H in the hydroxide would overall combine to form twice of H2O. Total 4H, na? Clear? So twice Ag, 4 NH3, H and 3H eliminates as twice H2O. So main concept is Toulon's reagent oxidizes aldehyde to acid and itself undergo reduction to form a precipitate of silver. That is important. Okay. Now the second test is Felling's test done using a Felling's reagent. Felling's reagent is a solution prepared in the laboratory by using Felling A and Felling B. Felling A and Felling B. Now this Felling A solution is cupric sulfate, which is blue colored solution, famously blue vitriol bhi bolte hain. And the Felling B has the NaOH alkali present in the bottle, and this alkali is present along with a salt called Rochelle salt. Rochelle salt, which is equivalent to chemically sodium potassium tartarate. Sodium potassium tartarate. So now to prepare the Felling's reagent, I mix Felling A with Felling B. So CuSO4 from A will react with NaOH from B. The copper now will combine with the OH to form its hydroxide CuOH twice, and Na and SO4 would combine to form a salt Na2SO4, and the balancing would be choice. Clear? Now when this reaction happens, there is a problem that the cupric hydroxide tends to precipitate, but then the testing needs to be done with the solution and we can't do it with the precipitate. So as soon as CuOH twice formed, we need to prevent the precipitation, और वही prevention का काम करता है Rochelle salt from the Felling B. So Rochelle salt, that is sodium potassium tartarate, is used to prevent the precipitation of cupric hydroxide. So now we have the solution of cupric hydroxide, which will be blue colored, and let's see the general reaction. It will affect only the aldehydes, so I have RCHO. This now in ionic form could be written as Cu with +2 and OH with minus. Here the ratio in which they react is now 2:5. मतलब excess of OH minus ions are present, so overall it reacts in the ratio 2:5. Now 2:5 कैसा है वो भी बता देता हूँ. If I use 2 moles of this, I'll get twice of cupric ions and how many OH? 4. But then aldehyde जो acid में convert हो रहा है, that is also reacting with a base, so it will consume 1 mole of extra NaOH. So how many total OH minus ions are consumed? 5. 4 from there and 1 for the acid. ठीक है, वहाँ पर भी यही था. 2 from the ammoniacal silver nitrate itself and 1 for the acid. इसलिए total 3 है. तो यहाँ पे 2:4 होना चाहिए था, but 5 क्योंकि एक एक्स्ट्रा है. ठीक है, so that is how the balancing is done. अब यहाँ पे aldehyde will once again oxidize to form acid, but that will get neutralized with the base to form the carboxylate ion. उसके बाद the cupric ion here being oxidizing agent will get reduced to cuprous ion, and this cuprous ion gets precipitated in the form of a oxide, that is cuprous oxide, and this cuprous oxide form is red in color. It's a red precipitate. So with the way of test, it's simple that the blue color, if it changes to red, it's a confirmatory test for the aldehydes. If it doesn't, it's a ketone. Clear? Now बाकी का balancing simple है. Cu2 takes away one of the oxygen Now total H कितना है 1 from here and 5 from here, सेम चीज, तो यहाँ पर कितना मिलेगा 6H के हिसाब से 5H2 and the reaction is balanced. Clear? Third, Schiff's reagent. Now Schiff's reagent has a very complicated formula, so we don't have the structure in the syllabus. We just have the theory part of the Schiff's reagent. Schiff's reagent is first of all prepared by using para-rosa-aniline hydrochloride. Para-rosa-aniline hydrochloride. It's an aromatic structure which is pink या dark pinkish में magenta colored. Magenta बोलते हैं, dark pink. ठीक है? So this rosa word actually refers to the pink color of the para-rosa-aniline hydrochloride. This para-rosa-aniline hydrochloride is first dissolved in water, diluted, and then it is continuously passed with sulfur dioxide gas. Very important. Passed with sulfur dioxide gas until the pink color decolorizes. So this SO2 would be passed until the pink color decolorizes. So at the product side, I'll get a colorless solution. This colorless solution is nothing but Schiff's reagent. So Schiff's is colorless. And now the reaction. When aldehyde is treated with the Schiff's reagent, the pink or magenta color reappears. जो original color है वो reappear हो जाता है. So if the colorless changes to pink या magenta, it's a confirmatory test for aldehydes. ठीक है? So इसका confirmatory test silver precipitate, इसका confirmatory test is blue to red, इसका colorless to pink. That's it. Point 1. Out of the 3 oxidizing agents, they are all first of all weak, but in तीनों में Fellings is weakest. Fellings is weakest. So it passes the test for all the aldehydes which are aliphatic, but it fails for an aromatic aldehyde. Because we know that aliphatic aldehyde versus aromatic aldehyde, which is more reactive, aliphatic. So benzaldehyde as it is बहुत कम reactive है और ये बहुत ही weak oxidizing agent है, इसलिए benzaldehyde Fellings को पास नहीं करता है. But it does pass the Tollens and Schiff's test. So very important, benzaldehyde does not pass Fellings test. ठीक है? Point 2. Apart from the aldehydes, this test are given with by the carboxylic acid also. But carboxylic acid में एक ही carboxylic acid है जो ये reaction देता है, and this is formic acid. Why? Because of the presence of aldehydic group. So these tests are also given by formic acid. Third, biomolecules में when I was discussing about cyclic structure of glucose and fructose, मैंने ये बताया था कि reducing sugars और non-reducing sugars का concept. Reducing are those which pass Tollens and Fellings test. Non-reducing are those which does not pass. बराबर? उसमें एक ही non-reducing sugar था सुक्रोज. बाकी चाहे अल्डोज हो, कीटोज हो, कोई भी डाइसैकराइड हो, वो सारे के सारे रिड्यूसिंग थे. तो वहां पर कीटोसिस भी ये टेस्ट दे रहे थे, बट यहाँ पर हम बोल रहे हैं कि कीटोन्स फेल्स द टेस्ट. बराबर? तो कीटोन्स डू फेल द टेस्ट, बट देयर आर सम फिक्स्ड कैटेगरी ऑफ कीटोन्स और स्पेशल कैटेगरी which are alpha hydroxy ketones. Alpha hydroxy ketones. स्ट्रक्चर कैसा रहेगा? कीटोन इज कार्बोनाइल, अल्फा इज बाजू वाला कार्बन और उस पे OH हो गया अल्फा हाइड्रोक्सी, और कीटोन है तो आजू बाजू R और R डैश रहेगा, लेट्स से यहाँ पे H. करेक्ट? नाउ ऐसे टाइप का स्ट्रक्चर अगर रहेगा तो क्या स्पेशल हो जाता है कि कीटोन भी ये रिएक्शन देने लगता है. इफ यू हैव अ कार्बोनाइल एंड अल्कोहल, did we have any reaction between carbonyl and alcohol? Acetal formation. If you remember, carbonyl reacted with the alcohol in presence of dry HCl to form acetal, या rather first step में hemiacetal and next step में acetal, जो हम बायोमोलिक्यूल्स में भी सेम कॉन्सेप्ट अप्लाई कर चुके हैं. क्या होता है? कार्बोनाइल एंड OH when they are together within the molecule, it will undergo intramolecular reaction to form hemiacetal as the intermediate, and those hemiacetals will have the tendency to pass the tolons and phelings. That's why alpha hydroxy ketones, ketosis from the biomolecules were able to pass the phelings and tolons and they were referred as reducing sugars. तो इन शॉर्ट 3 बहुत इंपॉर्टेंट चीजें इनसे याद रखनी है. phelings doesn't pass for benzaldehyde. Formic acid is the only carboxylic acid which passes the test, and this tests are also given by special category of ketones which is alpha hydroxy ketone. The reason behind them is formation of hemiacetal. एक ही है ना OH, तो hemiacetal.